Hey guys, I hope that I'm live right now. If you guys are able to hear me properly as well as there is no problem with the audio or the video, please do let me know. Hello everyone, I hope that I'm live right now. If you guys are not facing any issues with the audio or the video, please do let me know so that we can move on accordingly. Hello everyone, hello Aryan, great to see you again. So for I apologize for the previous 2 days. I had throat pain and hence I was not able to take up the classes for you guys. Um, Today as well, I have some throat pain, but I was feeling a bit better, so I decided to take up the classes anyhow. Hello everyone. Hello. So also had a great time meeting with my fellow students as well, who just graduated from our batches and got placement in various companies. So in the previous 2 days, I was busy talking to them as well, and it was an amazing journey. They gave me a lot of feedback as well as a lot of help from their own end. So it was great to see that the efforts that the instructors as well as the students are making it is actually showing some kind of results in their life. Right now I still have some throat pain, hence I'm not speaking a bit louder, but still, like, I'm fine. Like, I'm not that bad in shape. Okay, you don't have to worry about that. Hello everyone. Hello. We'll be starting in 2 minutes, guys. Like, I decided to take up the React and JavaScript bootcamp as well today, but my partner suggested that I shouldn't be doing that and I should just focus on one of the bootcamps. From tomorrow, I've already scheduled all the bootcamps for the next 4 days. Okay, and the timings as well as dates will not differ. I will be taking them properly. Um, One of the things. Yeah, Mohammed, thank you so much. I have not recovered fully, but yes, I'm in good shape so that I'm able to take up the classes today. Okay, so let us start with our today's class. If that's not a problem with you guys, please let me know in the live chat. Can we start off with the today's class? Please do let me know. Okay, great. So I'll just open up Collab. Let's open up the latest one, data types and operators. Okay, I'm not able to see the live chat. I will just open up the live chat on my mobile phone so that I'm able to see you guys as well. Give me a second. Okay. I'm getting some ads on my own channel. That's Give me a second, guys. I'm just opening up the live chat on my phone. Sure. So can someone remind me up till where we have covered the in the bootcamp, like up till where, or the topic that I covered last time? We were going to start off with NumPy and Pandas, if I'm not wrong. Am I? Can someone let me know? If I'm not wrong, we were going to start off with NumPy and Pandas. In that case, I will have to give you guys a new. I will have to give you a new link itself that you will have to use. Give me a second. There's so many study material that we have posted right over here. They're able to see. It's just too much. I will have to find all these things as well. So these are all the projects, as you're able to see, that we cover in our training and internship program. So there's a lot, many number of projects, and like there's a lot that we cover in the training program itself. So I'm just trying to find out the Python. Okay. So from here I can use this TV Python for data science. I think so. I can use. Yeah. So we have covered the basics of Python. Next, we are going to go into NumPy and Pandas. Okay, so we are going to do the basics of the same. I'm putting this link in the live chat as well as in the video, in the description of the video as well. So I will just remove this particular link and replace this. So if you reload your page, okay, uh, we were able to finish the tuple class. Okay, so the last that we did was tuple. So now we need to do the NumPy and Pandas. Okay, so the link I've already pasted right over here. You guys already know what we have to do. We just have to go on collab. So let's go on collab right back over here. It will open a page. Okay, I've opened the drive. Just Google Colab. Once you have opened up Google Colab, you will have various options right over here. The examples, recent, Google Drive, GitHub. We need to select GitHub from right over here. So we'll just select GitHub, and then inside of GitHub, we are going to paste our path here. That's Control V, and then I just need to search for the same. Once I've done that, it will open up the notebook in Colab. As you're able to see, this is the notebook for NumPy, the basics that we need to know for using in our deep learning program. Okay, so everything that we give you guys is extremely well made, well maintained, updated to the latest version, as well as everything is well documented. So as you're able to see, we have documented everything so that at any, including the notes as well as right over here, at any point of time if you want to refer to this, you can easily do that and learn a lot about these topics. Are you guys with me? Please let me know in the live chat. Are you guys with me? Please let me know in the live chat. Hello guys, please let me know in the live chat. Are you guys with me or not? Great. So let's start off with NumPy. Okay, NumPy stands for Numerical Python. It's a fundamental package for scientific computing in Python. Okay, there's a lot of mathematics involved in Python because you are using it for data science. What do you mean by data science? A science that involves data. Whenever there is data, there will always be a lot of mathematics that will be involved. And nevertheless, in normal programming as well, you will be going in and again inside for calculating various different things. So for that, Python itself is a very slow language. You need some operations, you need to do some operations, for example addition, multiplication, all these kind of stuff, that you need it to be fast. For example, if you had multiplication, if you wanted to multiply 20 by 5, there are two options. You can directly write 20 into 5, that will give you the answer, or you can write 20 plus 20 plus 20 plus 25 times, and that will give you the answer. For if Python is taking 1 millisecond to compute a particular operation, whether it be multiplication or addition, it will take 1 millisecond to give you the correct answer in case of multiplication, whereas it will give you 5 milliseconds to give you the correct answer in case of addition. So these type of optimizations need to be made, and for that a scientific computing package in Python is the NumPy, and it starts for Numerical Python. NumPy provides Python with an extensive math library capable of performing numerical computations effectively and efficiently. Like I said, you both require that, okay, it should use as little space as possible in the memory. For example, if you're writing 20 times like 5 times 20 and you're adding that up, it takes up more memory in your RAM or ROM. So depending upon that, you need to save up memory and do it efficiently as well. Okay, effectively and efficiently. These lessons are intended as a basic overview of NumPy and introduces some of the most important features. Okay. Are you guys I'm still having some throat pain, but do not worry about that. Okay, are you guys able to understand like just the concept of what is NumPy? Are you able to understand that? Please let me know in the live chat, guys. Are you guys able to understand the fundamental concept that okay, NumPy, what is it? Okay, if I'm asking you what is NumPy, you are able to explain it to someone. Amazing, amazing. You may be wondering why people use NumPy after all. Python can handle lists as you have learned in the introduction of the lessons. Okay, why do we require NumPy? You will be able to see. Even though Python lists are great on their own, we have already studied about Python lists if you remember. Python has a number of features that will give it an advantage over other Python lists. Okay, so we are going to see what does like why do we require NumPy at the end of the day. Okay, that is what we are going to do. One of the most important feature, like I said, is speed. Okay, when you are using addition to do something, it will take time. Whenever you are using multiplication, it will do it quicker. Okay, so that speed is the difference between what Python already has and what NumPy provides to it. Okay, when performing operations on large arrays, okay, on if you are having large lists or large arrays and you want to provide any kind of operation, NumPy can often perform several orders of magnitude faster than Python lists. Of this we are going to understand everything that I'm saying. Do not worry, we will be looking at examples, we will be trying to understand it. Do not worry if you haven't understood it as of this particular moment. Just be patient. When once we have started with the hands-on thing, you will be able to understand it pretty efficiently. Okay guys, so be a bit patient. Okay, great. The speed comes from the nature of Python arrays being memory efficient and from optimized algorithms used by NumPy for doing arithmetic, statistical, and linear algebra operations. We are going to look at it. Do not worry about the same if you are not able to understand it. Okay, because right now you don't even know what NumPy is. Okay, so once you are able to see what NumPy is, you will be able to understand. Right now just try to like keep this in mind. Okay, once we have started off with the basic NumPy package, we will mostly be dealing with some kind of arrays. Okay, what do I mean by arrays? I think so you guys have already know. Okay, there are various different types of arrays. So you are having your one-dimensional array that looks like a list. Okay, you're having your one-dimensional array that looks like your list. Then you are having a 2 by 2 dimensional array that looks like somewhat of a hexagonal pattern. Let me draw it and show it to you guys. Okay, so that you are able to at least understand what I'm trying to say. Give me a second. Okay, so what we have seen previously as of the lists was something like this. Okay, this is how a list looks like. Similarly, arrays, NumPy arrays also look very similar to this. But unlike lists, they do not have to be of one dimension. This is called as one dimensional array. You can have two dimensional array as well. That looks somewhat like a grid. Okay, it looks somewhat like a grid. You can have three dimensional arrays as well. Okay, that looks somewhat like this. Okay, you are having your three-dimensional arrays that looks like a Rubik cube or something like that. Of course, we cannot imagine a particular case in which it's a four-dimensional, but yes, a four-dimensional, a five-dimensional, and nth dimensional array also exists in NumPy. Now, in many cases, for example, if you guys have studied mathematics, you will know about matrix multiplication. Okay, you would know about matrix multiplication. Okay, that is like two, you are having two arrays that you need to multiply. Okay, you have two arrays that you need to multiply. So all these different attributes, all these different things that you want to accomplish in Python can be done using NumPy arrays. Okay, that can be done using NumPy arrays. Okay, we are going to see what those are, how we are going to use it. Okay, because I have left a lot of different things, because this is just a 7 days bootcamp. In the 15 days bootcamp, we spend almost a week just on Python. Okay, just on Python we spend across a week just to understand everything. Okay, right now I've covered Python in like 2 days. So do not worry about the same. So here, just to make sure like how to use NumPy in Python, first of all, you need to import the package. Okay, you need to import the package. You need to import the files that contain the code that can be imported and then used as the NumPy. Okay, so for that we can directly write import NumPy, that will import the entire NumPy function package. But I don't want to write NumPy again and again. So whenever you have to use that package, you will have to write NumPy again and again and again. So for that, I can nickname it. Okay, I can nickname it anything. Okay, but usually the convention is that I should nickname NumPy as NP. We are going to do pandas as well. That will be PD. But right now we are going to use NumPy, so we have to import it as NP. Okay, we can do it as something gibberish as well. But why do you want to do that? Okay, there is a particular convention that okay, whenever you want to import NumPy, you have to do it by import NumPy as NP. We are also going to import one more thing called as import time, another package that helps us to track time. Okay, time related functions that we want to do. For that we are importing time as a package as well. There are various packages in Python. You can even create your own packages. In the training and internship, we also teach you how to create your own package as well. But right now we are going to use the default packages, as you are able to see. So as soon as it has been done, we have already imported NumPy, and whenever we want to use NumPy, we are going to use it as NP. Okay, whenever we want to use NumPy, we are going to use it as NP. Okay, so x is equals to np.random.rand, and what I'm doing right over here, okay, I'm creating a very huge array of almost a billion. So I think so. This is a billion if I'm not wrong. Let us just check. Thousand. Million, yeah, it's a billion. So it's a billion elements long array. Okay, I'm creating a billion elements long array in which each of the elements is between 0 and 1. So for that I can use some of the functions and methods that NumPy provides. So one of those functions and methods are random.rand. Okay, so what does that mean? So dot rand basically generates like a billion long array. Okay, filled up with nothing. Okay, an empty array, empty NumPy array. Okay, of billion parameters long. Okay, then random basically assigns values inside of those elements. Okay, each of those elements are now empty, but I want to assign some random value between 0 and that is being done by random, and NP is the NumPy package that I'm using right over here. You don't have to know about it. This is just to show you how easy it is to create a very long arbitrary array in NumPy. Okay, so when I'm running this, it will create that entire array. So it will take some time to run because it is creating such a huge array for me, but once that has been done, it will be a very huge array. Okay, you don't have to worry about the same. Okay, so it took 13 seconds to run this particular line of codes, but in 13 seconds we have got a billion element long array right over here. Next, what we are going to do is we are going to check how much time does it take, okay, to calculate. So there are two things. Okay, we can calculate the what we want to do. We want to calculate the average of all the elements inside of x. Okay, x is a NumPy array. I want to calculate all the elements. I want to calculate the average of all the elements present inside of x. Now we are going to do it in two ways. First, using just Python. We are not going to use NumPy. We are going to use simple Python to calculate how much time does it take to calculate the average of this billion parameter long array. Okay, so for that, first of all, I need to check the start timing. What is the start timing? When does this particular line of code starts to run? Okay, that will be given to me by using the time package, that is time.time. That is the function that will return the current time when this particular line is being executed. Okay, it will return to me the current time in milliseconds, okay, at which this particular line has been executed. then I will calculate. So how to calculate the like average of a particular list or a particular array? I just have to write sum of x. Okay, sum that will return, just we had len of x. If you remember in list we had checked, if you want to calculate the length of a particular list, I just have to line len x. Similarly, if I want to calculate the average of a particular list, I just have to write sum x. As simple as that. So once I'm writing sum x divided by len of x, I will get the average, that is the mean, and that after that I just have to print. Okay, so time.time, if you remember, I said that it will give the current time at which this particular code was run. Okay, this particular line of code was run, and then minus start, that is the time at the beginning before running this particular line. Before running the second line, what was the time? I will subtract it via the current time itself, and that will give me the exact time it took to run this second line. Are you able to understand this? This is just like a stopwatch. Okay, you took this time at the start, you looked at your watch, it showed okay 12 o'clock, then you did something, then you looked at it, the watch, it was 1 o'clock, and you subtracted the two. Okay, you subtracted 1 o'clock minus 12 o'clock, and you got 1 hour as your answer. Are you able to understand up till here? Please let me know, guys. So when I'm running this particular code, you know what I'm trying to do. Are you able to understand this, guys? Please let me know. Okay, so let's run this particular line of code, and let's see how much time in seconds does it take to run this particular line of code. It will take some time, so we can have a good chat about the same. Okay, if you guys want to talk to me on the live chat, you can, because it will take at least 2 to 3 minutes, 2.5 minutes it will take to run this particular line of code. Okay, so in the previous 2 days we didn't had any class. Okay, did somebody try to do some of the assignments that were there inside the Python notebook itself? Did somebody try to do that? Okay, so some of the students like Akshat Jain have done it. Okay, great, Akshat. See, practice is like, coding is all about practice. Okay, if you're practicing the same, it would be better. Is NumPy built in Python? It's not built in, but yes, it has been built in Python. The code is in Python itself. Like, it's not exactly like in Python, like it's a hybrid between C sharp and C sharp, C++ and Python. So like it takes some time. Will the online collab affect the time? No, it won't. Like, it has some latency because it is sending the code to the server and back. So that is totally dependent upon how fast your internet is. Okay. Can you explain this code block again? Okay, so time.time gets you the exact time at which this particular code was run. Okay, that is the start time. Then you want to subtract it at the time at the end of the code itself, and the middle we are just using normal Python, okay, to calculate the mean of a billion element long array. Are you guys able to understand? As you're able to see, the billion element long array was so big that your RAM is almost filled. Are you able to see this? Your RAM is almost filled because that billion element long array, you're actually using it inside your code. Okay. To import NumPy in Python, you can directly write import NumPy as NP, like the first line of code that we discussed. Okay. So what does NumPy, like, why is NumPy faster than Python? So basically I've already, okay, so we have got the result, but I will answer this question. So what it does is, it uses, first of all, it is memory efficient, and it uses optimized algorithm for its like whatever it is doing. Okay, whatever type of code it is going to run, it will like use some arithmetic, statistical and linear algebra operations to optimize it, as well as it will like look for the best possible solution. Okay, it's like a bit complicated for you guys, but yes, it will result in a better answer at the end of the day. Okay, if you're getting module not found error, that means you haven't run this particular line of code. Import numpy as np, you will have to run this particular line of code, guys. Okay, as you're able to see on my screen, my answer came out as 168.9 seconds. It's 169 seconds. That is almost 2.5 minutes. That's almost 3 minutes itself. Almost. It took 3 minutes to run this particular line of code. Now let us look at what happens when we use NumPy. So again, we'll have the start time. Okay, again we'll be having your print time minus start to calculate the time it took to run this particular line of code. And right over here we are using NumPy. Okay, np.mean, it already has a built-in function, a built-in method for you guys. You can directly use np.mean x, that will give you the mean of the entire array x. Okay, so let us run this particular line of code, and you will be able to see that we got the same answer in less than 1 second. We got the same answer in less than 1 second, guys. I get different answer. So see, when Collab is distributing resources, it does not always distribute the same resources. I may be working on an i9th generation processor, you might be working on an i7th generation processor. So it takes some differences because the exact time to run a particular code can never be the same. But yes, it will be approximately the same. Okay. As you're able to see, we are able to get like a huge difference of almost 3 minutes between using normal Python and NumPy. And hence NumPy is the go-to solution for numerical computation, because you cannot wait. Even for very simple calculation, you cannot wait 2.5 minutes, because when you're going into deep learning or machine learning, each of these algorithms have billions of computations that you have to do at one time. If it is taking 2.5 minutes for each computation, it may take almost 3-4 years to do the same. Okay, so that is what you need to understand why we are using NumPy. Are you guys able to understand this? The speed at which NumPy works is something that is of a huge difference, guys. Are you able to understand? Please let me know, guys. Are you able to understand, guys? Please let me know. Internet speed may affect it due to some latency, but I don't think so. It plays a huge role right over here. Okay, creating NumPy ND arrays. Like I had already said, NumPy has not just one dimensional array, but like you can go to nth dimensional array as well. At the core of NumPy, in the ND array, where ND stands for n-dimensional, an ND array is a multi-dimensional array of elements of all of the same type. This is again a difference from lists. Okay, lists can contain like elements of different types, but ND arrays can only contain elements of all the same types. Like you cannot have like strings and integers or integers and floats in the same ND array. You can only have an ND array of integers, an ND array of floats, an ND array of bools. Okay, so you cannot have mixed race inside the ND arrays. Okay, in other words, ND arrays is a grid that can take on many shapes and can hold either numbers or strings. In many machine learning problems, you will often find yourself using ND arrays in many different ways. For instance, you may use an ND array to hold the pixel values of an image that will be fed to a neural network for image classification. Just to understand what I said right over here is, once you're using, so for example, you are making a machine learning model that predicts whether my dog is happy or sad. Just like, let's take that an example. So what is the input for this particular machine learning model? Can someone let me know what is the input for a machine learning model that clicks a picture of my dog being happy and then predicts whether he's happy or sad? What is the input to this particular application? Akshat Jain, I've already answered that question almost 3 times. Please pay a bit attention. Yes, Shashank, it is image. Okay, image is the input that we are going to take. Now let us consider what an image is. An image is nothing else but pixel values. Okay, let's try to understand this. So whenever you are having, so let us think of this as an image. Okay, so once I'm making an image, it contains of a lot many number of pixels. When you zoom in, when you look at your phone very closely, or your laptop or your TV very close to the face, you will be able to see some like small squares. Each of these squares contain three like LEDs. Okay, three LEDs that contain the value of red, green and blue. Okay, now RGB values together brings a particular color in that particular pixel, and these pixels together form your image. When you're taking an image as your input, it's nothing else but a three-dimensional array. It's a three-dimensional array in which the length and the width is that of the image, and the depth is the RGB values of that particular pixel itself. Okay, if it's a black and white image, then it's just like either it's white or it's black, so it's just a two-dimensional array. So arrays, when you're feeding in inside your machine learning algorithm, it needs to be feeded in as a NumPy array itself. Okay, it needs to be filled in as a NumPy array itself, so that the computer is able to understand what it is feeding you. The computer is not able to see these colors, the computer is not able to understand these colors, the computer is only able to see numbers. So it will be a three-dimensional or a two-dimensional array containing numbers that the model is able to understand. Are you guys able to understand this? Please let me know, guys. Great. So let's move on from right over here. There are several ways to create an ND array in NumPy. The following lessons, we will see two ways to create ND arrays using regular NumPy like Python list, that is to convert a particular Python list into NumPy arrays, or using built-in NumPy functions. In this section, we will create ND arrays by providing Python lists to a NumPy np.array function. It is just a function that returns an ND array. We should note that the purpose of clarity, the examples throughout these lessons will use small and simple ND arrays, and we'll start by creating a one-dimensional ND array itself. So let us look at this from this example. So we are having, first of all, we need to import NumPy. Okay, so we'll be importing NumPy as NP again. We want to create, so this is a particular list. As you are able to see, this is a normal list in Python containing 5 elements, 1 2 3 4 5. Normal list in Python. We need to convert it into ND array. To do that, we don't have to do anything, we just have to use the np.array function, and that will convert the a list inside the parenthesis into an ND array. As simple as that. So once we are printing it out, you are able to see that it looks the exact same as the list. Okay, but now it is an ND array. Okay, you can even check the type. Let's check the type right over here. You will be able to see that the type of X is now np.nd array, and originally if I am replacing this from here, control C, control V is equals to, let's change this to X, control X, X. Let's change this to here, and we'll remove the brackets from. So, and we'll just check the type of X here as well. As you are able to see, okay, type of X we need to print it as well. So as you are able to see, first of all, the X was a list. Okay, the X was a list, and then second of all, we converted using np.array, we converted it from a list to a ND array. Are you able to understand this? Please let me know, guys. Today there will be no JavaScript class. From tomorrow we'll be starting off with the React and JavaScript as well. Okay, are you able to understand this, guys? Please let me know. Amazing. Another important property of arrays is their shape. The shape of an array is the size along each of its dimensions. As you will see, NP arrays, ND arrays have attributes that allow us to get the information about them in a very intuitive way. For example, the shape of an ND array can be obtained using the dot shape attribute. The dot shape attribute returns a tuple of n positive integers that specify the sizes of each dimension. Let's try to understand this right now. Okay, you are having an ND array, so we are using again a particular list and converting it into an ND array right over here using np.array. Please don't forget that. Okay, then we are going to print x right over here, and then we are going to print some of the information about this particular ND array. For example, I need to see the dimensions of ND array. So as you are able to see, this is a one dimensional ND array with 5 elements. So it's like 1 cross 5. Okay, so the shape would be 1 cross 5. Okay, let's see. Instead of writing like 1 right over here, we can directly write 5 commas like nothing, because as you know that there cannot be a 0th dimension array. Okay, there cannot be a 0 dimension array. So the bare minimum is 1, that is by default, so we don't have to write it. Python does not feel it necessary to be written down. Okay, so we are getting 5 comma nothing, and that's the shape of our ND array. Okay, next we got the type of x. So the type of x is numpy.nd array, and then we are having another function in another method in Python in NumPy, x.dtype. Okay, dtype means data type. What is the data type of the elements present inside x? Okay, it's not the type of x, it's the data type of the elements present inside of x. And the data type of the elements present inside of x is integer, and as it is a 64-bit integer, we are getting int64 as our answer. Okay, are you guys able to understand this? Please let me know, guys. Are you guys able to understand this? Please let me know, guys. Great. Let's move on to the next. We can see that the shape attribute returns the tuple 5 comma nothing, telling us that x is of rank 1. Okay, these are called as rank 1 matrices. That is, x has only one dimension. Okay, if x has only one dimension, it will be called as rank 1. If x has 2 dimensions, it will be called as rank 2. If x has 3 dimensions, it will be called as rank 3. The tuple function tells us that the x is indeed a NumPy ND array. Finally, the data type attribute tells us that the elements of x is stored in memory as signed 64-bit integers. Another great advantage of NumPy is it can handle more data types than Python lists. So of course, we haven't discussed about every single data type that exists in Python. We have only discussed about very few data types. But yes, if you want to check what are the different data types that are present in Python, you can click on this link right over here, and you will be able to see more of it. Just to make it clear that lists can contain multiple data types in a single list. Okay, but they have like limited number of data types that they can use. Whereas in case of ND arrays, they can only have a particular ND array of one data type, but there are many more data types that ND array can use. Okay, if you are interested in the same, knowing the same, you can just click on this particular link. It will take you to a new page. Do explore it a bit. Additional knowledge is something that will never be harmful for you. Okay, it will always help you in your interviews. Okay, these type of questions are something that will be asked in interviews, guys. Okay, of course, learning Python is important, but just not the practicality, but a bit of theory is also important, because they will be asking you theory in the interviews. Yes, they will be asking you to show practice as well. You will be practicing it, you will be coding it in the interviews, but not just coding it up. You will need to know the basics, you will need to know the theory as well. Keep that in mind. Okay, in our training program, we focus upon both of them. That's why, as you're able to see, each of these notebooks is made in such a way that the students are able to understand both the theory as well as the practicality behind every single thing. As mentioned earlier, ND arrays can also hold strings. Let us see how we can create a rank 1 ND array of strings in the same manner as below. providing the np.array function a Python list of strings. So right over here, as you're able to see, it's the same thing. You don't have to do anything else. Okay, you're having a list of strings. You want to convert it into an nd array, as you have done right over here. Then you are able to have an x is equals to, so you are just printing it out. You will be printing out the shape of x, that will be 2 comma 0, because there are just two elements right over here. And then the type of x would be again nd.array, but the data type is something that will be changed, because now the data type would be strings. When I'm running this particular line of code, you are able to see that we are having your x, the dimension is 2 comma nothing, 2 comma 1, and nd array is something that we are going to get, and u5. Okay, so that unicode 5 or something like that, if I'm not wrong. So that is also one of the standards for the string data type itself, that is written right over here. So you don't have to worry about it. It's string for you guys right now. Okay, it is important to remember that one of the big differences between Python lists and nd arrays is that, unlike Python lists, all the elements of an nd array must be of the same data type. We have already discussed upon this many number of times. Please remember this. Okay, if you are having more than two data types in a list, like Arpit has asked, you will get an error. Okay, it will never be made. Okay, please remember this. So while creating the Python lists with both integers and strings, we can't mix data types in nd arrays. We provide the np array function with a Python list that is both integers and strings, as Arpit had asked. NP will interpret all the elements as strings. Okay, for example, right over here we are having 1, 2 and world. So it is having integers as well as strings. So if I'm trying to run this particular line of code, you will be able to see that it has interpreted everything as a string itself. You get an error. You don't have integers in your nd array as of this particular moment. And this has been changed to u21. That is again a Unicode 21. That is a type of strings itself. Okay. So are you guys able to understand this? Please let me know, guys. Are you able to understand this? Please let me know. Are you able to understand this? Please let me know, guys. Yeah, Arpit, as you are able to see, I'm also getting the same thing. Amazing. Let us now look at how we can create a rank 2 nd array from a nested Python list. Okay, so right over here, this is a rank 2 nd array. Let's try to understand how do you define a two-dimensional nd array using Python. Okay, so let's try to create a two-dimensional. Okay, let's try to understand this. Okay, so it's very easy to understand. Okay, so for example, when I am having a one-dimensional nd array, you are having 4 elements in this. How will you make the list? Like, you'll be having like this and then 4 commas. That's it. Okay, as simple as that. Now if you are having a two-dimensional nd array, the same thing, just in 2 dimensions. Okay, how are you going to make, how are you going to interpret this? It's nothing else but 4 different, it's nothing else but 4 different one-dimensional array. Are you able to understand this? It's nothing else but 4 different one-dimensional array. Okay, now these 4 different one-dimensional array together, okay, if you consider this as 1 element, 2 element, 3 element, 4 element, are connected together in one giant matrix. Are you able to understand this? Please let me know. Great. So if I'm able to represent a single array like this, I can also, let me just rub this from right over here. work. What I'm going to do right now is I'm going to replace each and every one of them with their array. And then I will just put up a larger array to fix it up. So I will enclose it into a larger array, put commas between them, and that's how you create a two-dimensional array, how you represent a two-dimensional array mathematically. Are you able to understand this? You have a two-dimensional array, you split it up, you put it inside one giant array, and that is how you get a two-dimensional array. Because a two-dimensional array is nothing else but a one-dimensional array in which each of those elements is again a one-dimensional array. Are you able to understand this? Are you able to understand this, guys? Please let me know. Great. So now we are going to use the same thing right over here. So we are having a particular list, a two-dimensional list that we have created using the same formula. What we have discussed right now, we have created the same thing using a two-dimensional list, nothing else. Okay, and this is how you create a two-dimensional ND array. Okay, you can check the shape, you can check the size, okay, you can check the type. Okay, so right over here you are able to see the shape. So the shape is 4 comma 3. Okay, the shape is 4 comma 3, that is, it is having 4 rows and 3 columns. Always remember rows first then columns. Okay, always remember rows first and then columns. Yes, exactly, Manish. It's just like list having another list inside of it. Okay, it has in 4 rows and then columns. Always remember R first then columns. Okay, RC. Okay, you are using RC remote control cars. Always remember rows first and then columns. So these are 4 rows and 3 columns. Now you can even use y dot size. Okay, you can even use dot size method. Okay, as you're able to see here, we have used dot size method to find how many elements does this two-dimensional array have. That is 4 into 3, that is 12 elements that this n-dimensional array has. Then the type and the data type, that is numpy.nd arrays and integer 64. Are you able to understand this? Please let me know, guys. Are you able to understand this, guys? Please do let me know. Amazing, guys, amazing. I just need to create the attendance for day 4 if I'm not wrong. Why do we get int 64? What does it mean? So that is like signed 64-bit integer. Okay, it's a type of integer in which it takes 64 bits, okay, to store every single integer. And like you can have the integers up till 64-bit. That's what I'm saying. 32, that's how it works. And it's a sign, that is, it contains both positive as well as negative values. So attendance link for Python and deep learning day 4. Okay, I'm sending it right now. Shorten the URL. You guys can take a screenshot for the same right over here if you are able to. Same. For a 32-bit computer, of course, you are not doing it on your own computer. You are doing it using Colab, like that is on the servers itself. But yes, if you are having a 32-bit computer, it will show different results, or it will like not be able to store huge numbers, okay, that extend beyond 2 to the power 30 or something like 2 to the power 16 itself. That will be the problem. Well, if you are getting this error called as no module not found, you have to write import numpy.np and run it. NumPy as NP. That is the problem. np.array is something that creates, it's a function, it's a method that is used to create an nd array. And np.nd array is basically like you are just calling it what is the type of this particular object. So that's nd array. Okay. Okay, so I've shown the attendance link. So that would be it for today, guys. We will again be meeting tomorrow, same time. I won't be skipping any more classes. I've already scheduled the classes for tomorrow as well. You can go and check it out right now. So we'll meet tomorrow. Those students who are interested in the Campus Ambassador program, definitely join it. There we provide a many number of goodies as well as monetary compensation as well. Like stipend is something that no other Campus Ambassador program is going to provide you, as well as it's a proper internship. So of course you can join, network and connect with many other students of your own age as well as some of the instructors as well. So do join the Campus Ambassador program. We'll meet tomorrow at the same time. Thank you so much, guys. Have a good day. Thank you guys.